Oh, hello there, everyone. You thought you weren't going to see me today, and yet here I am on the big screen with you. Right, milady? Whatever it is. Okay, so we are going to continue on with our multiplicative comparisons lesson. And remember, we're doing it with area and perimeter, because that's a good way to look at a visual, good way to use multiplication, to understand how everything is working together. So what I'm going to do is I'm going to share my screen. Should be able to see that, correct? Yep. Okay. And we're going to work through this together. Everybody, you guys have this? No, you do not have this, but that's okay. You don't need to have this because I have work for you to do afterwards in packets. And they actually look like this, okay? Very similar to what we did yesterday. So let's open up your math notebooks. Make sure you have your writing utensil. And let's work through this together. You do not need to have this page in front of you in order to do it with me, because you can obviously draw these same things. So let's look at this first problem. So a rectangular porch is 4 feet wide. It is 3 times as long as it is wide. First thing we're going to do is we're going to label the diagram. So if in your notebooks you do not have the diagram, which you shouldn't, go ahead and just draw 3 boxes together. They do not need to be perfectly symmetrical, okay? We're drawing 3. And then we need to label it width, 4 feet wide, okay? Looking at that, are we going to use the top that's separated into 3 sections, or are we going to use the side that's separated into 1 section? We're going to use the side, right? Because that's our width. So we're going to put a 4 on the side there. It's a little bit tough to do with my finger. So there's our 4. It is 3 times as long as it is wide. Well, if the top we can label as 3 times our width. Now think about all the other stuff that we've been doing before when we're going through word problems, everything. We have width equals 4, so W equals 4. The length equals 3 times W, which means that the length is 3 times 4. Good. And what is 3 times 4, everybody? In 3, 2, 1. Very good. It's 12. Awesome. So that means I'm just going to put on the bottom of this that it's 12. So we have 4 for the width. We have 12 for the length. And we get that from the multiplicative comparison of 3 times as long as wide. Everybody good? Make sure you have it written down. I'm doing this for you, not for me. I already know this. Please make sure you have it written down. Okay, so B says find the perimeter of the porch. Do you remember what we use for our formula for perimeter? So P equals, and we're talking about perimeter of a rectangle. P equals what? 2 times length plus width. Multiplicative comparison again, right? 2 times length plus width. Very good. Okay, so we use parentheses first, right? We can actually, this is just a fun little tidbit, we can actually do this as well with distributive property. 2 times L plus 2 times W, right? There's multiple ways of doing this. Math is awesome. So let's do this top one first. So what is L? Again, we know that L is 12. Very good. And what is W? W is 4. So 12 plus 4 is 16. So our perimeter is 2 times 16. Well, what's 2 times 16? 2 times 10 is 20. 2 times 6 is 12. 20 plus 12 is 32. So we have a perimeter of 32 feet. Okay. Now, if we were to do it the second way, 2 times L. So 2 times L is 12, so 24. plus 2 times W. W is 8. Sorry, W is 4, so 2 times 4 is 8. 24 plus 8 is 32 feet. Doesn't matter which way we do it, as long as we're using the distributive property or multiplication, we're going to get the same answer. So our perimeter is 32. Make sure we have this written down. Now, the important thing about this multiplicative comparisons is understanding how a formula works from the words and how do we fill it in with the information that we know. And again, it's a know, think, why, but it's in formula, it's algebra. So I'm going to erase this stuff. How do I erase all of it? I'm going to delete, clear all drawings. There we go. Been a bit since I've done this. So for those of you that might not need to see it a different way, I'm going to show it right here. So if this is 4, then this side is 4. Does that make sense? The left side is 4, then the right side has to be 4 because it's a rectangle. Yes? Okay, good. Now, the 3 times as long as wide. We can see the 3 times, right? But that means if it's 4 times 3, I know these don't look like squares, but the thing is, when it's a diagram, it doesn't need to be exactly how it is as long as the label's correct. So really, this is a 4, a 4, a 4. That's 3 times 4, another 4, another 4, and another 4, another 3 times 4, because if one side is there, the other side has to be, correct? So now, multiplication-wise, how many 4s do we have? 1, count them with me. 2, 3, 4, 5, 6, 7, 8. Well, multiplication facts, what's 8 times 4? 32. Now, that's going to be the most basic way of doing this, but I want us to see how we use those formulas for the multiplicative comparisons. Okay? Let's delete that. And let's keep moving. How do I? There we go. Okay. Number 2 says a narrow rectangular banner is 5 inches wide. It is 6 times as long as it is wide. A, draw a diagram of the banner. It says a narrow rectangular banner. Narrow. Narrow. What does narrow mean? Thin, right? Thin, smaller. So let's just draw a thin, long rectangle. Again, it does not need to be perfect. Please do not erase your rectangle. We all know how to draw rectangles. Please do not erase it. Okay. Using what we know, it is 5 inches wide. Our width is going to be that smaller part, right? So I'm going to label this as 5. And then if I want to label everything, if that's 5, what's the other side? 5, right? They're going to have the same thing. It is 6 times as long as it is wide. So this is 6 times width. Our no, right? So what we have here, W equals 5. Length equals 6 times W. Well, what's W? 5. So it's 6 times 5, which means that length is 30. So then just to keep this all similar, at the bottom I'm going to put 30 because we have 6 times W on the top. We have 30 on the bottom. That way we have everything labeled. Okay, so now we're going to look at our multiplicative comparisons, and we're talking about that 6 times 5, because 6 times as long as wide, and we're going to create formulas to find our perimeter and area. Okay? So what is our formula again for perimeter? If you do not remember off the top of your head, look at the previous problem. That's why we need to write stuff down. What's the previous problem? 2 times length plus width. Very good. So let's fill in those things, okay? Perimeter equals, from what we have, 2 times, well, what's the length? Yes, it could be 6 times W, but we already know from over here what length is. What is length? 30, good. And what is W? We already know it's 5, excellent. Okay. Order of operations, we can do those parentheses first. What's 30 plus 5, everybody? 35. So we have P equals 2 times 35. And what's 2 times 35? This is where we have to use our multiplication, right? What's 2 times 30? 60, good. What's 2 times 5? 10, good. When we add those together, what do we get? We get 70. So our perimeter, that's the distance around. So if you look at this TV, right? It's the distance around the TV, okay? Our perimeter is 70 inches. I'll give you a couple minutes to write that down, then I'm going to erase the perimeter part, and we're going to go back and we're going to do area. You have room in your notebook to do the area. Start erasing from this side. Okay, so we have a perimeter of 70 inches. Now let's do area. Who remembers what the formula for area is? Raise your hands, please. Formula for area. Don't be calling it out. I didn't ask for you to call it out. Casey, what's our formula for area? Very good. Length times width. Awesome. Length times width. Israel, I said to not yell it out. I knew. Over there eating your toenails, yelling. What? I didn't say anything. Nothing. Stop. Okay, area. Area is length times width. Awesome. So now we're going to, this is just normal multiplication, right? Okay. What's our area? What's our length? We're going to fill it in. Our length we know is 30. What's our width? 5. 30 times 5. This is just multiplying with tens, right? 30 times 5. If 3 times 5 is 15, good. Then 30 times 5 has to be 150. Excellent. So it's 150 inches squared. And what that means is if you had a square inch inside of a banner like this, you could fit think about like those tiles, right? Those tiles are about a square inch. You could fit 150 of those things all together inside of this banner. So the perimeter is 70 inches all the way around. So if you were to use a ruler or a tape measure, you could measure around it 70 inches. And then inside square inches would be 150. Okay? Make sure that's written down. I'm deleting. 5, 4, 3, 2, 1. All right. Next problem. Let's go. Oh, I gotta exit out of this again. Okay. So how many more we got here? We get through F. Cool. So we did 1 and 2. Let's go 3. I love it. So this is where our understanding of how words and numbers are working together is going to be huge. And again, we're going to switch over to these visuals because I think it's going to help a lot more people. Eventually, you're not going to need to have the visual, but for right now, let's do the visual so we understand what's going on. 3, the area of a rectangle is 42 square centimeters. Before we do anything else, let's just draw a rectangle. The area of a rectangle is 42 square centimeters. Okay, well, I know area is What is it again? Everybody, what's area? Space. An area in this case is the space inside of something, right? So the area of the rectangle is 42 square centimeters. Let's label that. 42 centimeters squared. The length is 7. So I'm going to use the top, and I'm going to go 7. This is division or multiplication facts, right? Because what is, Casey said it before, what is our formula for area? Everybody, area equals length times width. Very good. Let's just fill it in. Now that we know this, area 42 equals 7 times width. Well, if you know your facts, 42 equals 7 times 6. Excellent. So what's the width? The width is going to be 6. And if you look at this, isn't this our area model? This is our area model. If I were to take, where's my eraser? If I were to take, oh no, wait a second. How do I go back? Yeah, perfect. If I were to take my eraser and get rid of these, and I just had a box, okay, with 7 and 6, what would you do with those two things? You would multiply them to get 42. This is being able to work backwards. Number sense is huge. Visuals are huge. How do we make these things always work? Now let's look at B. I'm going to write that back in. Hold on, sorry. 42 centimeters squared. Okay. Now B. Charlie wants to draw a second rectangle that is the same length, but is 3 times as wide. Okay. Do I care that the name is Charlie? No, we don't care. Some other person wants to draw a second rectangle. So let's draw a second rectangle. I don't care how perfect it is. It does not matter. It is the same length. Well, look at our previous problem. What was the length? 7. Very good. So I'm going to label it 7. I know it's not the greatest. Label it 7. Okay. But is 3 times as wide. So this is going to be on our width part, 3 times, I'm going to make that a little bit better. 3 times W. Does that make sense how we're combining those? We have 7 as the length, so that's the same, 3 times as wide. We're not talking about 3 times 7. It's not 3 times as wide as the length. It's 3 times as wide, 3 times W. Well, what was W from our previous? It was 6. So that means it's actually 3 times 6. And what is 3 times 6, everybody? 3, 6 times 12, 15, 18. Or if you like the 6 is better. Ooh, I think that I found a way to count by 6, 12, 18. Right? It is 18. So we now have a rectangle that is 7 by 18. If you look at my pictures, even your own pictures, is your second rectangle larger than the first one? No, it's not. It's not. It could be, it might be. Some people's might be a little bit larger, okay? Some people's might be smaller. Some people's might even be a different shaped rectangle. Does that matter? No, because it's a diagram, okay? We have a map of the world. You can put a map of the world on a picture that's this big, but you can also have a globe that's up there, and you can have a map that goes the entire length of this room. It doesn't matter because it's a diagram. It depends on what we're talking about. Okay? Everybody have that written down? Let me exit this out for a second. I want to see what else we have. Okay, we got what's the perimeter. So let's do perimeter next. I'm going to bring this back here. So C is what's the perimeter. So perimeter. We have a formula for perimeter. What's the formula for perimeter, everybody? P equals 2 times length plus width. Very good. Hopefully I'm not just sitting here in my room doing my regular thing. Hey, look, everybody. Who's going to call me? Who's going to call me out? Everybody gets a PBIS point. Let me give you a PBIS point right now. I'm pulling it up and I'm going to give it right now. All right. So here we go. You are responsible. We're selecting all. Responsible. Select all. Okay, everybody's got it. And then boom, everybody gets a pirate buck. Good job. It's delicious. Sorry. Okay, perimeter equals 2 times length plus width. So P equals 2. What's our length? 7. What's our width? 18. Good. 7 plus 18. What's 7 plus 18? What is it? What is it? 25. Very good. So P equals 2 times 25. Well, what's 2 times 25? This should be one of the ones that we already know. You know how much a quarter is, right? How much? How much is a quarter? 25 cents. If you have 2 quarters, how much money do you have? 50 cents. Very good. So 2 times 25 is 50. So our perimeter is 50. Very good. Even though it's not a question, what would we do to find the area? 18 times 7. 7 times 10 is 70. 7 times 8 is 56. So we would go 70 plus 56, standard algorithm, and we get an area of 126. What were we working in? Centimeters. 126 centimeters squared. Cool? Yes? All right. Very good. Let's delete that. Everybody has that written down? 5, 4, 3, 2, 1. Stay with me. Let me exit out that. Okay, we did this. So I think it's just question 4 left, but there's A, B, C, and D components. Oh, sorry, A, B, C, D, E, and F components of this. This will be the last one that we do. And then you have your own work to do. It's your own packet. So inside of this packet, okay, it's everything that we've done. I've got 1, 2, 1, 2, 3, 4. It's literally the same thing. It's an exit ticket, and then it says homework on it. Do I give homework? No, I do not. So it's classwork, and I need that classwork done. It will be done. Those will be turned in. Does that make sense? Good. Okay. And I need to see work on it. Nothing in your head. I need to see the work. That's mandatory. Okay. Where's my annotate? Annotate. There we go. The area of Betsy's rectangular sandbox is 20 square feet. The longer side measures 5 feet. The sandbox at the park is twice as long and twice as wide as Betsy's. Okay, a lot of words, could be confusing. We don't want to be confusing. We don't want to be confused. We break it down. What do we know? Well, let's draw some stuff. We know that Betsy has a sandbox, so we're going to draw the sandbox. B equals, there's a sandbox, and it says the area is 20 square feet. Where's that square feet going to go? Inside or outside? Area. It's going inside, so I'm going to put a 20. Now, your brain should be going crazy right now with all these different possibilities, just like in literacy, right? We need to be using inferences. If I see that 20 is on the inside of a box, okay, it's my area. There's only so many different ways that we can go here, because we know that in order to get the inside, what operation do we use? Everybody? Multiplication. Well, there's only so many things that can equal 20, right? It could be 1 times 20. It could be 2 times 10. And it could be 4 times 5. That's it. We're not talking about fractions yet. Those are the only things that could be 20. So it's going to be a width of 20 and a length of 1 or vice versa, a width of 2, a length of 10 or vice versa, a width of 4, length of 5, vice versa. That's it. That's all it can be. And having those things running through your head is going to make you ready for this problem. So there's our first part. The second part, the longer side measures 5 feet. Ah, dang it. I drew a square. Does that matter? It does not matter. Do not erase. If you drew a square, do not, or what looks like a square, don't change that. The longer side measures 5 feet. I'm just going to choose a side and I'm going to label it 5. And then it says the sandbox at the park. Is the sandbox at the park Betsy's sandbox? No, it's not. This is something else that I know. I'm going to put a P equals. I'm going to draw another sandbox. Is twice as long and twice as wide. So let's label. 2 times L, 2 times W. Simple enough, right? This is the stuff that we know. This is the stuff that we know. And now this allows us to solve. So let's go back and let's think. If we know that there's only 3 different multiplication facts that can get us 20, let's go back to Betsy's. We need a width, don't we? Well, we can do 20 divided by 5, or we can do facts, 3rd grade facts, the ones I need you to know. 5 times what equals 20? 5 times 4. Good job. So Betsy's is done. 5 times 4, 20. Boom, done. Well, let's do the park. Well, what's 2 times W if W is 4? That's 8. What's 2 times L if L is 5? That's 10. And if we're filling it in, what's the area of our park here? 10 times 8 is 80. Done. Everything is filled in now. Now we got to go back to A and B, though. Draw and label a diagram of Betsy's sandbox. We did that. So I'm going to put a little check. Boom. What is its perimeter? We didn't solve that yet. P equals 2 times length plus width. P equals 2 times 5 plus 4. P equals 2 times 9. What's 2 times 9, everybody? 18. So P equals 18. That is Betsy's. B, draw and label the diagram of the sandbox of the park. Check. What is its perimeter? P equals 2 times L plus W. Keep up, please. I'm writing with my finger on a computer. Please keep up. P equals 2 times, what's L for this one? 10, very good, plus 8, very good. What's 10 plus 8? 18, so P equals 2 times 18. 2 times 10 is 20. 2 times 8 is 16. Add those together and we get P equals 36. We have a perimeter of 36. We have a perimeter of 18. I'll give you a couple seconds to write that down. And again, writing this down is going to be huge for your work afterwards because you're going to be able to use this with the stuff that we're doing with your worksheets. Now look at C. C says, what's the relationship between the 2 perimeters? I love that question. Relationship. If we see that, does that mean they're dating? Is 18 and 36 dating? Are they loving each other? No, I don't think so, right? They're not loving each other. We don't have 18 over here. Ooh, 18, Android 18. No, we're not talking about that. 18 and 36, are they in love with the relationship? No, they're not in love. No, that's not what we're talking about. Stop thinking that. No, relationship. If we're talking about numbers, we're talking about relationships. What are we doing? How do they work together? So 18, how does it become 36? What could we do? You could add them. 18 plus 18 is 36. Yep. What else? 18 times 2 is 36. Good. There's two other things we can write. What would the subtraction be? Yep. 36 minus 18 equals 18. And then what other operation do we use? Division. 36 divided by 2 equals 18. Those four right there are the relationships between Betsy's sandbox and the park's sandbox. They're not in love. They're not in love. No, they're not. Okay. We have find the area of the park sandbox. We already did that. We see this is yes, perfect. We already did that. We already did that. No, did we do it? Yes. Yeah, we did it when we were labeling it because that's how we label. We said it was 80, right? Perfect. We're already done with that. The sandbox at the park has an area that is we already did that with the relationship. The sandbox at the park has an area that is how many times that of Betsy's sandbox? What do we have there? 18 times 2. Perfect. It's 2 times more. And then F, this is our last one. Compare how the perimeter changed with how the area changed between the two sandboxes. Explain what you noticed using words, pictures, or numbers. So you already did your diagrams, so we're not going to worry about that. And honestly, I can't even remember what I had. Now I delete it. So let's think about this. How the perimeter changed. So Betsy's perimeter, what did we say it was? I already deleted it. It was 5 and 4. So that was 2 times 9, which is 18. So Betsy's is 18. And her area was 20, right? And then the park's perimeter, 10 and 8, that's 18, was 36. And the area was 80, right? Perfect. Okay. So compare. How comparing is when we're looking at different two. We can do greater than, less than, or equal to. We can compare them by understanding, oh, hey, we multiplied by this, we divided by this. So compare how the perimeter changed with how the area changed between. So perimeter increased. What is that? That is not letters. Perimeter P increased 2 times, right? Let's just do that. And then what could we say by area? Area increased. How many times did the area increase from 20 to 80? 20, 40, 60, 80, 4 times. Very good. And that's how they compared. Our perimeter increased by 2 times, and our area increased 4 times. Sweet. All right, so that is what we have for math today. Continuation of what we did yesterday. I'm going to stop this share. Continuation of what we did yesterday. You guys have a packet, and again, I'm going to bring it back up. So it's got page 44. It's front and back. 44, 45, 46, 47, and 48. There's 5 sheets, which is more than enough work. Okay. I need your names up here. They have to be up here because if it's collected and I don't see a name, you're not getting any points for it. Okay. So the first thing you need to do when they're handed out, please put your name on it. Today's date is 11/9/2023. Make sure that date goes on there. And I want that whole thing figured out with diagrams. When I come back and I see those, I want to see formulas. I want to see diagrams. I want to see labels. Okay. All right. Yeah. Cool. We'll see you later. Bye-bye. Good job. Thank you, guys. Peace.